All right, here's a couple more examples of solving systems of equations by substitution. So this one is almost all by itself, right? So we want to try to get the variable all by itself so that we can then plug it into the other equation. That's what substitution is. So we're going to divide both sides of this by 2, and we're going to end up with y equals 3x plus 5. That's what this one actually equals. So we know y equals 3x plus 5. Well, we also know that this is 3x minus y equals 5. So we're going to plug this that we already know for y in where we see a y. Anywhere, since these two are equal, anywhere we see a y, we could also put this. These two are the same. So I can plug this in anywhere I see a y. So I'm going to say 3x minus 3x plus 5 equals 5. Oh, and don't forget that when we plug this in for y, that minus or negative sign out front is out front of the entire y. So this applies to everything that we plugged in. So this really becomes 3x minus 3x, and then this negative distributes in, and that becomes negative 5. So let's combine like terms. 3x minus 3x is actually 0, and so then we still have minus 5 equals 5. So we have negative 5 equals 5. Whoa. That can't happen, right? Negative 5 can never, ever, ever equal 5. It's just not possible. So this means there is no solution. And remember what that looks like on a graph. It would be two parallel lines that never meet. No solution is two lines that have the same slope, so they never touch, and one of them is just shifted down a little from the other. So this one has no solution because the answer that we came out to can never, ever, ever work. Negative 5 never will equal 5. All right, last one. We're going to get one of these variables by itself, and then we're going to solve by plugging that in. So neither one of these is really pretty because all of them have a coefficient in front of the variable. So let's just pick one. We're going to call this one, we're going to get this one by itself. So we're going to say negative 3y minus 4x minus 5. So we subtract 4x from both sides, and we end up with this. Then we're going to divide both sides by negative 3. We get y equals 4/3 x plus 5/3. Yay, fractions. So y equals 4/3 x plus 5/3. Okay? So anywhere we see a y, we're going to put that. So here we have 5x plus 7y equals negative 17. So we're going to go 5x plus 7 times 4/3 x plus 5/3 equals negative 17. Let's squeeze that in there. All right, let's write that down here. So we have 5x plus 7 times 4/3. We'll remember that 7 over 1 times 4 over 3. So 7 times 4 is 28. 1 times 3 is 3. So 7 times 4/3 x is going to give us 28/3 x plus 7 times 5/3. Well, 7 times 5 is 35. 1 times 3 is 3. So 5x plus 28/3 x plus 35/3 equals negative 17. Whew, all right. Well, let's combine like terms here. Well, 5x and 5 and 28/3 can't combine because they don't have common denominators, right? This is 5 wholes. Well, what if we cut each one of these into 3 pieces, right? Then we have 5 over 1 times 3 over 3, right? We just cut each of these pizzas into 3 pieces. So 5 times 3 is 15. 3 times 1 is 3. So now we have 15 thirds x. So we can add them together now. 15 thirds x plus 28 thirds x. Since they're the same size pieces, we just add the top numbers together, and we end up with 43 thirds x. Now we still have plus 35 thirds equals negative 17. We need to subtract 35 thirds from both sides. And again, so these cancel out. These don't have the same denominator. So we're going to have to give them the same denominator. 43 thirds x equals, so we need to multiply this by 3. Well, negative 17 multiplied by 3. So negative 17 times 3 over 3 gives us negative 51 over 3. Negative 51 over 3. All right, so we have 4 thirds x equals negative 51. Oh wait, that is negative 51 thirds is 17. Negative 51 thirds minus 35 thirds. Whew, yeah, I almost forgot about that. So then we can combine these and we end up with 43 thirds x equals negative 86 thirds. I'm running out of room here. All right. Well, let's just get rid of that 3. Let's multiply both sides by 3. And we end up with those 3's cancel that out. So we have 43x equals negative 86. Wow, that looks a lot friendlier, doesn't it? Then we divide both sides by 43. We have x equals negative 2. Wow, love those fractions, right? All right, so that means the x-coordinate where these two lines cross is negative 2. We're going to plug that back into one of these. So we're going to say 4 times negative 2 minus 3y equals negative 5. That's negative 8 minus 3y equals negative 5. Add 8 to both sides. We have negative 3y equals 3. Divide by negative 3. Divide by negative 3, and y equals negative 1. Wow, look at all that mess. Okay, so our final answer is x equals negative 2 and y equals negative 1. So it's the point negative 2, negative 1. And that is the point where these two lines cross. It's the only point that these two lines share.